Ever wished you could just, download your chores to a robot?
Wow.
Here you go, take care of this. Wouldn't that be the dream?
It would make life a lot easier, that's for sure.
Well, today's deep dive is taking us a step closer to that reality. We're talking cutting-edge AI, specifically how it learns to navigate the real world.
Exactly. We're moving beyond AI that can just chat or recognize images.
Yeah.
We're talking about AI that can actually do things like, actually tidy up the house instead of just telling you what tidy means.
Right, like a robot that understands that putting away the dishes doesn't just mean making them look nice and neat on the counter.
Exactly. It's about understanding the goal, the steps involved, and the how those actions actually change the environment.
So how do we get there? Our source material this time is a research paper, a bit of a mouthful. It's called MLLM As ReTriever, Interactively Learning Multimodal Retrieval for Embodied Agents.
Catchy title, right?
Definitely rolls off the tongue. But seriously, this paper introduces something called MART, right?
Yes. MART stands for MLLM as Retriever, and it's basically like giving an AI agent a superpowered memory system.
Okay, a memory system. So instead of just throwing information at the AI, it can actually hold on to what it's learned and use that to make better decisions in the future.
Precisely. Think of it like this. Imagine you're learning a new skill, like, say, playing the piano.
I am terrible at piano.
Well, imagine you could rewatch recordings of your best attempts, the times you hit the notes perfectly.
Okay, so like a highlight reel of successes.
Exactly. And you could study those, focus on what you did right, and learn from those successes much faster. That's essentially what MART enables AI agents to do.
So instead of just fumbling around in the dark, they're learning from experience.
Yes. And that's crucial because real-world tasks are rarely straightforward. They involve multiple steps, decisions, adjustments. You wouldn't believe how many microactions go into something as simple as making a sandwich.
Okay, so you're saying there's a lot more to making a sandwich than meets the eye?
Absolutely. And without a system like MART, AI agents end up wasting a lot of time and energy on inefficient actions. It's like trying every single possible combination of ingredients before stumbling upon the right one.
Okay, so MART helps AI learn more efficiently, but does that actually translate to better performance?
That's the exciting part. The paper shows that MART significantly outperforms other methods, especially in more complex tasks. They gave the AI agents a task: navigate to the dish sponge, put it in the plate, and place the plate on the cabinet. Simple enough, right?
It's pretty straightforward, yeah.
Well, this seemingly simple task actually involves a whopping 73 individual steps for the AI agent to break down.
73 steps just to put a sponge away.
You see, without MART, it's easy to get lost in all those steps. But with MART helping the AI prioritize and focus on those key actions, their success rate shot up to 80%.
Wow, 80%. That's a huge difference. So we're not just talking about making the AI a bit faster, we're talking about making the seemingly impossible possible.
Exactly, and this is just the beginning.
So MART is helping AI agents learn faster, smarter, more efficiently. But we've tossed around this idea of cause and effect. What does that actually look like when we're talking about, AI and robots?
It's a great question. Think about something most of us probably take for granted, like, say, heating up food in the microwave.
Okay, microwaving food. Got it.
We understand that putting the food in the microwave and turning it on, that's what causes it to heat up. But for an AI, that connection isn't always so obvious.
So it's not just about knowing the steps, put the food in, press the buttons. It's about understanding that those actions have a specific consequence in the real world.
Exactly. And MART helps AI agents start to grasp those cause and effect relationships. In the paper, they gave agents a task like, go to the bedroom and pick up the blue book. Something that sounds, again, very simple, but without that understanding of how actions connect, it becomes a lot more difficult.
And how did the agents using MART perform with that kind of task?
With MART, over 80% accuracy, consistently.
Wow. Okay, so color me impressed. But I have to ask, how do you actually test this stuff? Are we talking about building a whole virtual house for these AI agents to run around in?
You're not far off. They used a couple of different simulation platforms for these experiments. One is called AI2-THOR. It's specifically designed to mimic realistic home environments.
So virtual kitchens, living rooms, all that.
Exactly, with all the objects and layouts you'd expect to find. The other environment they use is called LEGENT, and that one focuses more on common household tasks, so things like fetching specific objects or navigating between rooms.
Okay, so we've got our virtual world, we've got our AI agents, we've got MART acting as their superpowered memory guide. But how do the researchers actually measure how well it's working? What are they looking for?
Two key things. Success rate, meaning how often the AI agent actually completes the task, and then average steps taken.
So even if two different agents both manage to, say, put a dish in the dishwasher, the one using MART might be able to do it in like half the number of steps.
Exactly. Because it's learned to prioritize the most efficient actions, the ones that get it to the goal faster.
Which makes sense. I mean, in the real world, efficiency is key. Nobody wants a robot butler that takes 3 hours to make a cup of coffee.
Exactly. And speaking of efficiency, the researchers wanted to see how MART stacked up against other approaches, so they tested it against a few different methods. Some used pre-trained models, others relied on simpler retrieval methods, like just matching keywords or finding similar images.
So instead of looking at what actually worked in the past, these other methods were more like, oh, this image looks similar, let's try that.
You got it. And while that can work to a certain extent, it often misses the nuance of real-world tasks. It's like trying to learn how to cook just by looking at pictures of food. You might pick up on some basic ideas, but you're not going to be a master chef anytime soon.
That's a great analogy. So MART clearly outperformed the competition. But I'm curious, how did the researchers know that every part of MART was actually necessary? Did they try, like, taking pieces away to see what would happen?
They did. They ran something called ablation studies. Basically, they removed or altered specific parts of MART to see how each component contributed to its overall performance.
So it's like taking apart a clock to see how all the gears and springs work together.
Exactly. And one of the most interesting ablations was when they removed the trajectory abstraction component, which, remember, is that ability to focus on the most important actions within a task.
Right, the highlight reel of successes we were talking about earlier.
Exactly. And when they took that away, MART's performance definitely took a hit.
So it was still able to learn, but it was slower, clunkier, less elegant.
Exactly. Like trying to learn from a cooking show where they show you every single second, even the boring parts like waiting for water to boil.
Okay, so trajectory abstraction, definitely key. But did they experiment with any other parts of MART?
They did. They also tried separating the different steps involved in MART's learning process. So instead of having MART handle both the retrieval of past experiences and the ranking of those experiences based on relevance, they tried making those separate steps.
So it's like, instead of having one system that can both find and recommend restaurants, you've got one system that just lists every restaurant and another that tries to rank them without knowing what you like.
That's a great way to put it. And it turns out keeping those two processes together, the retrieval and the ranking, that's a big part of what makes MART so effective.
Interesting. So it's not just about the individual parts, but how they all fit together.
Exactly. And that's what makes this research so exciting. It's not just about finding a slightly better way to do something. It's about rethinking how AI learns and interacts with the world.
So it's like we're not just giving AI a slightly better tool, we're fundamentally changing how it learns.
Exactly. And that's what makes this research so promising. But like you said earlier, every technology has its limitations. So what are we still working with here?
Right, because as much as we love to imagine these like super intelligent AI butlers, we've got to stay grounded in reality. So what are some of the challenges the researchers highlighted with MART?
Well, one of the big ones actually surprised me a bit, given how much we've been talking about, visual information. Turns out that even with these powerful AI models we have now, their ability to process multiple images at the same time, it's still a bottleneck.
Well, it's like they've got this whole visual dictionary in their digital brains, but they can only look up one word at a time.
That's a great way to put it. Right now, MART is designed to retrieve one highlight reel, one successful trajectory at a time. So it's like saying, okay, AI, focus on this for now, learn from this, and then we'll get to those other memories later.
So even though there might be this huge library of past experiences they could learn from, like they're having to take it one book at a time.
Precisely. And while that's a great starting point, think about what AI could do if we could unlock that ability to process multiple trajectories simultaneously. It's like instead of just watching one cooking show, they could analyze techniques from dozens of chefs at once.
Now that you mention it, that sounds less like a roadblock and more like, the next challenge to tackle. Imagine if, by expanding that visual working memory, we could actually unlock a kind of AI imagination.
Now you're thinking big picture. If AI could actually hold multiple possibilities in mind at the same time, start to combine those elements in new ways.
Instead of just mimicking what they've seen before, they could start to invent, right? Come up with new solutions, new approaches to problems.
Exactly. The researchers even hinted at that, suggesting that this could allow AI agents to actually splice together skills from different trajectories.
Yeah.
So learning to cook from different chefs and then coming up with your own unique dish.
So moving beyond just heat the potato or put the dish away, they could actually start to improvise, experiment, maybe even teach us a thing or two about efficiency in the process.
Now that's a future I'm excited about.
Me too. But even with those limitations in mind, this research still feels like a pretty big deal, wouldn't you say?
Absolutely. This is a significant step forward in embodied AI learning. And while we're still in the early stages here, it's exciting to see these developments.
Yeah.
It really makes you wonder what's next.
It really does. It's enough to make you think twice the next time you see one of those robot vacuum cleaners puttering around.
Right. They might be learning more than we realize.
Exactly. Well, on that note, I think we've covered a lot of ground today. We'll have to wrap up this deep dive. But for everyone listening, remember, the conversation doesn't end here. Keep exploring, keep asking questions, and most importantly, keep that sense of wonder alive.
I couldn't have said it better myself.